Students, let us explain the link state algorithm with an example. And this graph is already familiar to you. And in this slide, I will explain only the initialization part. The algorithm initialization part looks like this. N dash is initialized with u. So you can see here the initial value of n dash is u. And for all nodes v adjacent to all nodes v, if v is adjacent to u, fill dv with c of uv. So all the adjacent nodes, the first row is filled with the list of nodes other than u. So the list of nodes other than u consists of 5 different nodes: v, w, z, y, and x. v, w, x, y, and z. And d of v and p of v are the distance to v and the predecessor of v. Distance to w, the predecessor of w, like that. And it to u means from u to v. u to v, we can reach with a cost of 2 and the predecessor is u. From u to w, the cost is 5 and predecessor is u. And cost of u to x is 1 and its predecessor is u. There is no direct path from u to y and u to z, so it is filled with w. This is what the initialization part does. Now the second half of the algorithm is inside the loop. From step number 8 to 15, inside the loop, it will pick one node at a time. In one iteration, one node is chosen and it is added into the list of n dash. Then the second row, that is the step number 1. Step number 1 is filled by updating the d of v. This is the main part of the algorithm. How the d of v is updated? It is written in the step number 12 with the red lines. That is, dv is equal to minimum of dv, comma, dw plus c of wv. The minimum among d of v or dw plus c wv. The value of this second row, that is step number 1, 2u is filled, that is finding the filling the table by checking the minimum of d of v. d of v represents always the previously found value. That is, 2u is the previous value to reach to v. Either that, or is there a new path from u to v through x? As per the algorithm, we can find that to v from u through x there is a path. 1 plus 2 is the cost and the predecessor is x. So 3x is there. Then the comparison is in between 2u and 3x. Whichever is minimum, that is filled into the next row. So 2u is smaller than 3x. So 2u is repeated to the second row. Then next w4x is filled. It is checking whether 5u or is there a path to w from u through x. Yes, there is a path to w from u through x. u to x, x to w, 1 plus 3, 4. So 4x or 5u, whichever is minimum, that is copied now. So 4x is minimum, that is a value stored into the dv. So the new value of dv is 4x. Then we don't bother about dx because already x is chosen into the list of n dash. Then what about y? The previous value of y, d of y is actually, it is infinity. So the minimum of either infinity or is there a path from u to y through x. Is there a path from u to y through x? Yes, it is there. 1 plus 1, 2. So 2x or infinity, whichever is minimum, that is copied into the next row. So 2x is minimum. Still, we are not able to find a path to w. So it is filled with infinity. Then step number 2. So we are selecting one minimum value from the previous row, that is 2u or 2x. Both are same value, so any one of these can be chosen. So in this case, I have chosen 2x. That is, y is the node. So y is added into the list of n dash. If I am selecting 2x, the node respective to 2x is y. So y is added into the list of n dash. Then next is again the same thing is repeated. That is, the table has to be filled. So previous value of 2u or the current value means, is there a path to v from u through y, there is a path. Is there a path to v? No. So 2u itself is copied down. Then again for dw, previous value is 4x, and if there is a path from u to w, through x, yes, it is there. There is a path from u to w through y, that is 1 plus 1 plus 1, 3y. So through y there is a path. Is 3y or 4x is minimum? 3y is minimum, so it is copied down to the next row. We are not bothered about dx because x is already in the list of n dash, y is already in the list of n dash, so these two rows are skipped. And the next is there a path to z? Yes, there is a path, that is a minimum of infinity or the value to z through y. Is there a path? Yes, 1 plus 1 plus 2. So 4 through y. To reach to z through y, there is a path and the cost is 4. So it is again filled with 4y. Then the minimum is 2u. So v is added into the list of n dash. Then again we have to fill the next row, that is step number 3. Is there the path to w? 3y is already there. Is there is a path, new path or a better path to w through v? W through v, there is a path. Its cost is 2 plus 3, that is 5. uv is 2, vw is 3. 2 plus 3, 5. And the 3y is better than the 5v. So 3y itself is copied down. And the case of z, dz, there is no path to z from v. There is no path to z from v. So the previous value is 4y itself. So it is the minimum value. 4y is copied down. Among 3y and 4y, 3y is minimum. So the w is chosen into the list of n dash. And in the next step, we have only 4y and the z is added into the list. And this is how the distance table is modified and n dash, the list of n dash is created. So the aim of the second half of the algorithm is to identify the list of nodes or add up all the nodes to n dash. This is how the algorithm works. Now we are able to create the shortest path tree, and this will be the entries in the forwarding table. So to reach from U to the destination V, the link chosen is UV. Similar to that, for every other destination, the link chosen from U to reach that particular node, which is the selected coast path, that is filled to create this tree. This is how the algorithm explains. Thank you.